Here's a walkthrough of Gateway 4. So the sections here, you'll notice that the Gateway really only includes these last few sections that we've been doing. So it's pretty focused, which is good. So that means that with a little bit of practice, you should have no trouble with this. We're evaluating log base 7 of 1 over 49 in our first problem. And there really are two ways to do this. You can do this as a calculator problem, or you can use your knowledge that 49 is actually a power of 7, and there should be something simpler that we can do. So let me skip that one real quick and do number 2, because number 2 will give us the calculator way that we could do the other one if we wanted to. We learned that there's a change of base formula says that when you want to do log base 6 of 10, you just do the log of 10 over the log of 6, and you can use whatever log button you want on your calculator. So you can use your LOG button or your LN button, and LN 10 over LN 6, for example, will be the same value as log base 6 of 10. I'd encourage you to do it both ways, just so you can see that even though the individual numbers there are not going to be the same, it's worth checking to make sure that you believe that really is true. Anyway, so this would be approximately equal to, let me grab a calculator. Okay, so my answer is 3 decimal places, so 1.285 is the approximate answer to 3 decimal places. So that's super easy. That's just a calculator thing, so it's a formula that you should know for evaluating logs. If we apply that same idea to number 1, we will get the answer, but it will turn out to be an exact answer. It won't have all the decimal places, and you might wonder why. So let me just show you why this turns out to be a whole number. Well, it might not be a whole number, but it turns out to be a nice number. And it's because, remember, if we have a question, if we think of this as a question, the log base 7 of 1/49 equals blank, right? That's really supposed to be in parentheses there. That's the same thing. It's equivalent to saying 7 to the question mark equals 1 over 49. So those two things are the same. That's an exponential function, an exponential equation with base 7 on the bottom, and a logarithmic equation with base 7 on the top. And so the difference between the two is just that the inputs and outputs are switched. So did I say 4.9? That's just a scribble. Sorry, 1 over 49. So the reason this solves the problem is because 49 is 7 squared, so this is really 1 over 7 squared. And we learned that one of our rules of exponents is that an exponent in the denominator is the same as a negative exponent. So overall, I have the equation 7 to what power is equal to 7 to the negative 2 power. And so the answer is that the mystery power should be negative 2. I would encourage you to try doing number 1 using the formula in number 2 and see that you really do get negative 2 as your answer. Solving a logarithmic equation is as easy as converting it to the other kind, the exponential. So don't forget that ln is log base e. So if you want to just scribble out the ln and write log base e there, it will feel like you're doing the same problem. A log base e logarithmic equation is equivalent to a base e exponential equation. So e to the something equals something, and the inputs and outputs get swapped. So the role of 4 and 3x plus 7 are switched. So the 3x plus 7 is going here, and the 4 is going here. So that is the equivalent equation. These two equations say exactly the same thing. But this one has the x freed up. So this one is easy to solve. So I can subtract 7 from both sides, and then divide both sides by 3, or I like to just think of it as multiply by a third. So a third of e to the 4th minus 7 is the exact answer to that equation. And in all cases here, unless it says approximate, we do want the exact answer. So be sure on the gateway that you're including that answer and not don't put it in a calculator or do anything with it unless it tells you to. Okay, page 2, you see we have just lots of equations. That's what I was saying. This gateway, all the questions are very, very similar to each other. So with some practice, people generally do well on this, but you have to get to the point where you can do 3 of these in a row. What's the exponential equation that's equivalent to this? Well, we can see that this is a base 2 logarithm, And so it's going to be equivalent to a base 2 exponential equation. So it'll be 2 to the something equals something. And the x minus 7 becomes the output of the exponential, and the negative 6 becomes the input. And so I'll say 2 to the negative 6 equals x minus 7. And in this case, that's all it wants to know is what is the equation. It doesn't ask me to, it's not asking me to solve it. So that is the equation, the exponential equation that's equivalent to the given log equation. The next few of these are problems where we're solving things. So that means we're just going to convert to the other type. Remember, our first step is to rewrite the equation so that the exponential or log part, wherever the x is stuck, is by itself on one side. But in number 5, it's already like that. The left side of that equation is the exponential part of this equation. So I know that this will be equivalent to a log base e equation. And notice that I always do this. I want to say what kind of equation I'm getting, and I leave everything blank, and then I go back and say, well, what are my inputs and outputs? It's a little easier doing that than it is just trying to write it down left to right as you're reading the problem. So I know the exponential base e becomes log base e, so the bases are the same. That's why we call them both bases. And now the 14 here is the output, so that's going to go inside the log, and the 5x plus 4 is the input to the exponential, so it's the output of the log. So I'm just switching the role of input and output. And in this case, it's asking me to solve the equation, so I'm not done yet. That's plus 4, sorry. Got a little too excited there. So to solve that for x, I need to subtract 4 from both sides, and then multiply both sides by 1/5. So take a second to do the algebra to get the x by itself, and see if this is not what you get. And so if you check the answer to this, with the answers, you'll see that this is exactly what it says, except it doesn't say log base e, it'll just say ln. And so you could leave it as log base e if you want to. I do want you to know that log base e on your calculator is the ln button, but this is a perfectly correct answer. Here we can do exactly the same thing. There's nothing wrong with it. But if you notice, both sides of this equation both have powers of e in them. And so that means that this might be easier than using logarithms if I were to write both sides of this as exponents with the same base. So the left side is that e to the x plus 4. The right side, that fraction, is the same as e to the minus 3, right? That was on the previous page as well, that 1 over a power is the same as a negative power. And so if x plus 4 is equal to negative, so e to the x plus 4 is equal to e to the negative 3, then because e to the x is a one-to-one function, that means that the inputs have to be the same. So what we're saying here is that if you take the e to the x function, putting an input of x plus 4 and an input of negative 3 yield the same output. Well, because the e to the x function doesn't turn over on itself, so it's always going up, always increasing, the only way you can get the same output is if the inputs are equal. So we're not saying we're like crossing out the e's, we're just saying that the only way for outputs of the e to the x function to be equal is if the inputs are equal. And now this is a simple equation to solve, and we see that x is negative 7. The same thing would happen for logarithms. If we had two equal expressions, two equal expressions using the log with the same base, then the same argument would apply, because the log functions also are strictly going up or strictly going down. They don't turn over. So they also have the property that the only way you can get the same output is if you put in the same input. Okay. Same thing's going on in number 7. This will challenge us a little bit to make sure we recognize powers of the same thing, but we know the rule on this side. We're multiplying powers of 3, so that means we add the exponents. So this will be the same thing as 3 to the 2x minus 2. So knowing your rules of exponents well is essential. And then 729 is not a value that most people know, but it's 9 times 81. And we know 81 is 9 squared. So this is actually it's 9 cubed, or 3 to the 6th power. So that's a pretty big power. If you didn't recognize that, again, at any point you can solve this using logarithms. We could rewrite this as a logarithm base 3 equation and get the answer. But it's actually going to end up being a lot easier than that if we do recognize we have the same powers, because, I mean, the same bases, because then the exponents have to be the same. And for 2x minus 2 to be equal to 6, x would have to be 4. In this equation, I don't think I'm going to be able to, well, I don't know. You never know. Let's just see what happens. Remember, my first step is to get the equation to look like a single exponential equals a number, which is what we did here first. Right? We combined these things on the left side so that we had a single exponent equals a number. And we were lucky that both sides were powers of 3. So I'm going to play the same game here. If I want to get that 5 to the x plus 2, this term, if I want to get that by itself, I'm going to first divide both sides by 3. Oops. Got too many 5s. So 5 to the 5x plus 2 minus 5 equals 120. Right, so that's what I would get if I divide both sides of this by 3. Now I add 5 to both sides. And so now my equation now has an exponential on the left and a number on the right. And so I have a choice now of what to do. I could just go this route, we did up here. I could change the exponential equation into a logarithmic equation and go from there. But you might have noticed that similar to number 7, 125 is actually a power of 5. 125 is 5 cubed. So if you recognize that, now you can just set 5x plus 2 equal to 3. The exponents have to be equal. Let me do it with the logs, just so we can do one more like that. So you can see how it would work out if you don't know that 125 is 5 cubed. It's not a big problem. What we would do is we would rewrite this as a log base 5 equation. So instead of an exponential base 5, it's going to be a logarithm base 5. And the 5x plus 2 now is going to be the output. And the 125 is going to be the input. And so if you evaluate this thing on your calculator, again, using that change of base formula, so it's log 125 over log 5, for whatever log button you want to use, you'll find that this is actually 3. And so you'll have 3 equals 5x plus 2, which is the same thing same place we would have been before. So even if you don't recognize that 125 is 5 cubed and just use logarithms, the first thing that's going to happen is, if you know how to evaluate logarithms, is that you're going to have to take the log base 5 of 125 and you'll get the answer of 3, and then you're back in business. So in this case, what's x? A fifth? It's like x equals 1/5 is my answer. So at number 9, again, this is just asking for the logarithmic equation. It's not asking us to solve it. Well, this is a funny equation. So this is really strange because it's got a 7 on both sides. Mostly they won't. All we're really trying to do here is rewrite this as exponential. Rewrite it as logarithmic. So we want to just rewrite it as an equation that looks like that. So instead of a base 7 exponential, it's a base 7 logarithm. And of course the input and output would be switched. So you want to resist the urge to solve these. If it says find the logarithmic equation, that's it. Just leave it just like that. So that question is just practicing that step. In number 10, we're asked to solve g of x equals 5, but we're told what g of x is. So if you put those two things together, what it's really asking you to do is to solve this equation. The log base 6 of x plus 7 equals 5. Right? That's all that asks. So to do that, because the x now is stuck inside of the logarithm, I'm going to convert this to a base 6 exponential equation, and the 5 and the x plus 7 are going to swap, and so now the x is free, and so the value of x is just 6 to the 5th minus 7, and you can just leave it like that if you want to. That's perfectly fine, but 6 to the 5th is not an enormous number, so you could just ask your calculator what that is and actually find it. So this is actually a whole number. So it's not terrible to calculate, but it's not necessary. You can just leave it like that.